Okay, in this video we're going to have a look at PWM, that's pulse width modulation, on the Scamp board. And I'm using the Scamp3 board. It's an upgrade from the Scamp2 board. You can see it's a little bit longer, has a longer bus, has more features, has the same microcontroller, just a different package. And if you look at the very left, we can see a reset pin, and we have 3.3 volt output, and then we have a 0 to 11 GPIO pins, so we have 12 GPIO outputs. We have a clock, that's a system clock, that's 16 megahertz. Then we have the I2C bus, SDA and SCL. We have the SPI bus. Then we have the serial bus, that's UART1 and UART2, TX and RX, and they're hardwired to these pins. And then we have a VIN, so we could power this board from an external power supply. But in this video, we're going to look at PWM. Now there's 6 channels of PWM on this PIC microcontroller, and we could assign any one of those channels to the GPIO pins 0 to 11. And I have pin 2 connected up to this LED on the very left. So I could send some PWM signal to this LED, and I could demonstrate how we could run PWM on the Scamp3 board. Okay, the PWM output from my microcontroller is mapped to my keyboard. So every time I press the up key, it'll increase the PWM percentage by 1%. When I press the down key, it'll decrease the PWM percentage by 1%. So right now it's 0%, my LED is out, so I hit it once, that's 1%, 2, 3, 4, 5, 6, 7, 8, 9. There's 10%. Now if I hold it, we take it all the way up. There's 50%. Take it all the way up. There's 80%. And I hold it. There's 100. I can take it down by 1%. Or if I hold it, the auto repeat key will take it all the way down to 0. There's 0%. My LED is out.
Okay, I have TerraTerm up and running on my computer, and it's connected to my Scamp3 board. Now from the OK prompt, I could type words, and we could see all the words in the dictionary, and I'll do that. Type words. So these are all the words in the dictionary. Now these are little chunks of code that we could use to make our programming a lot simpler. And all those protocols that we saw on the front of the Scamp3 board, there's support for all those protocols here in the dictionary using these words. Now the 3 words that we're going to use for PWM are right here. It's period, duty, and PWM. Now period is the time it takes for one on-off cycle that we saw in the scope, and 1 over the period is the frequency. So that's how many one on-off cycles happens per second, and that's in hertz. And usually for controlling an LED, I use 300 hertz, and for controlling the speed of a motor, I use about 2 kilohertz. Now the duty is the ratio of the on-off time in that one period, and it's in percentage, and we can set up the duty cycle, and then PWM sets up the pin number for the 6 channels. So we have 6 channels of PWM, and we can assign that to any of the pins on the GPIO. So that's what PWM does. So we're going to look at these 3 words, and we're going to write some code that we could set up PWM so we can control the speed of a motor and the brightness of an LED using the Scamp3 board.
Okay, we only need 3 lines of code to set up our PWM channel on a Scamp3 board. So first of all, we have to set up our frequency. So I want 300 hertz. I use 300 hertz to control the brightness of an LED. So we take 16 megahertz and we divide it by 300. And we'll get a value of 53,333. So at the OK prompt, we type 53,333, 6. That's our channel, period. And I'll set up channel 6 for a 300 hertz output. So next is our duty cycle. So if we want 50% duty cycle, we take 53,333 times 50 divided by 100. We'll get a value of 26,666. So at the OK prompt, we type 26,666. 6 is our channel duty. That'll set up a 50% duty cycle on channel 6. So this value here, this 50, we could put anything in here from 0 to 100 to give from 0 to 100 duty cycle. And our last is setting up the pin. So that's our pin output. So pin 2, channel 6 PWM, so our output will be pin 2. So GPIO pin 2 will output our PWM signal using channel 6. So those are the 3 lines that we need to set up the PWM on a Scamp3 board.
Okay, here's the code running on my Scamp3 board for my PWM output. So there's the 3 lines. It's all you need to set up PWM on the Scamp3 board. So the first line sets up channel 6 for 300 hertz. Second line sets my duty cycle. I got it set for 0% in case I have a motor connected up. I don't want it to run right away. And my third line sets pin 2 is my output, and I'm using channel 6 PWM. So once we run these 3 lines, everything's set up and ready to go. So I made another word called %PWM. So now, after these 3 lines run, all we have to do is type a value between 0 and 100. So say 80, and then %PWM, and that will give us an 80% PWM signal, and we can monitor that on the scope. So that makes it handy now. So now my last word was PWM.LED. That was when I mapped it to my keyboard. So here when I do my up key, it takes my PWM value and increments it for my %PWM, and if I do my down key, it decrements my value, my PWM value, my %PWM. So there's my keyboard control. And so we could use that for testing. So we could hook that up to either an LED or a motor. And then we could just use our up keys and our down keys to control the speed of the motor or the brightness of the LED.
Now to control heavy loads with a PWM signal from a microcontroller, we need some sort of driver, because the GPIO pin in the microcontroller can only source or sink about 8 milliamps. So we're limited to just controlling an LED. So to control heavy loads, we need like a MOSFET to drive the load. So in my case, instead of building a MOSFET circuit, you can buy these little modules like this one here. This is a little MOSFET driver, has input voltage, and it has an output, PWM output, and it has 2 MOSFETs, 2 N-channel MOSFETs, and they're in parallel to increase the current capacity. And then we have our trigger input on these pins here. So I'll hook this little module up to the Scamp3 board, and we can drive some heavy loads using PWM. Okay, I have a high intensity LED connected up to my MOSFET driver, and it's being controlled with my Scamp3 board, my PWM output on pin 2. So if I use my keyboard and I'll give it 1%, so that's 1% duty cycle PWM, and I'll bring it up. It's going to get bright, so I'll take it right up, all the way up to 100%, and I'll take it down, back down to 0. So that's how we can control some heavy loads using PWM using the Scamp3 board. Okay, I have a little DC motor connected up to my MOSFET driver board, which is being controlled by the Scamp3 board, the PWM. So I'll give it some PWM output, and we'll speed up the motor. We'll get it going. There she goes. I can increase the speed and take it back down. So this is another application for PWM DC motor control. Okay, here's the schematic diagram of the MOSFET driver board, and you can see the N-channel MOSFET. It's a D4148. There's actually 2 of them in parallel to increase the current capacity. We have a resistor from the gate to source. It's a pull-down resistor, a 10K. We have an indication LED, which indicates if there's any PWM input, the trigger input, with a resistor in series, a 1.8K. And we have a series resistor, 100 ohm, into the gate of the MOSFET. Now there's 2 connectors. There's one on the very right, it's your V in. There's one on the very left, that's your V out, PWM out, and that's where you connect your load. And the input is 5 volts to 36 volts. So we just hook up our input and our output, and that's where we connect our load, and it's pretty simple. So this is easier than building a circuit from scratch. You just get the module, plug it in, and hook it up to the Scamp board, and away you go. Okay, so that was my little tutorial on how to get PWM going on the Scamp3 board. So all you need is some kind of MOSFET driver, like this one here. And I did add a freewheeling diode onto the output connector for inductive loads. Now there's 6 PWM channels on the microcontroller, and you can get them all up and running at the same time, and it's not taking any resources out of the microcontroller. So this is very handy for robotic applications, and everything is on board the chip. It's running FlashForth and has support for PWM, so it makes coding very simple.